Welcome, everyone, and thanks for being here. I'm very excited to have our guest, Terry, here today, Terry Walters. I'm going to let him introduce himself, um, but he is a resident here, and I was able to hear his presentation at the Ladera Firewise and Preparedness Fair and thought that this is something that we should offer to the entire community. So look forward to hearing what he has to say tonight. Go ahead, Terry. It's all yours.
Okay, thank you. Um, I'm a resident of Woodside. We live up near Skyline, off of Highway 84. We're on a fairly sizable property, but this is there's real. I mean, this is real wildfire danger area up here. So hence my concern and my work on the property here. So okay, so let's get this started. Let me share my presentation here. Um, and I'm assuming you can see this.
Yep.
Okay. Um, so uh, I'm not a professional in this business. I'm simply a homeowner like everyone else who's on here, I believe. And these are my observations and my opinions. And I could be completely wrong. And if you do what I did, you might be in trouble. But so just don't sue me. Okay. Um, This is our house, 3,000 square feet, two-story, has a perimeter foundation and detached garage. It's a stick frame mostly, post and beam. The exterior siding is T111. It's tongue and groove redwood siding. Uh, it's built in 1971. The lot is a sloping lot. The wooden decks on first and second floors, composition roof, originally wood shake. Double pane commercial windows, originally single pane windows in here. And over the years, I've been kind of worried about wildfires in this area, of course. And so um, I started thinking about how the advance of the wildfire would actually start my structure burning. And, we all became aware of this, quite a few years ago. Airborne embers are going to arrive first. They're probably going to get inside the structure if we're not careful and could burn the structure inside out. Wind-driven ember piles, as the fire approaches, embers will get larger and eventually start piling up along the bottom edge of the siding of the house and in corners, doorways, rooftop valleys, gutters. Um, and that can ignite exterior parts of the house without, you know, um, and the embers don't have to enter the house. Burning vegetation adjacent to the house can start the siding burning and could flame up all the way into the eaves. And then, of course, a wooden fence attached to the house could create a pathway for the fire to travel directly to the house. Radiant heat from a structure nearby, um, could ignite vulnerable areas around the house without direct flame contact. But in my case, we're on a large lot and there are no structures nearby. And the sort of guideline, my understanding is that if you're more than 40 feet from the wall of your neighbor to your home's wall, the radiant heat problem is not going to affect your property. But places like Pacific Palisades, where houses were so close together, radiant heat from one house could possibly ignite the structure next door. Um, our house had all classic problems. We're built in 1971. People weren't considering wildfires in 1971. We had a shake roof, exposed rafter tails. You can see these exposed rafter tails on here. Um, we had shrubs literally growing up into the eaves, and we have these. They're called Dutch gutters. They really they really don't lend themselves to having gutter guards put on them. So um, we had a new roof put on, meeting Class A requirements for materials and construction. Um, a Class A roof is kind of the first place to start, I guess. It's the first place we started when we started hardening the house. And more recently, I've looked up the standards on uh, YouTube to see videos of people actually testing roofs in accordance with this ASTM
I
E108
know.
standard. There are standards laboratories around the country that will actually test all this stuff. And so, if you have a roof that's a metal roof or a shake roof or some kind of tiles or whatever, and they're tested to this standard, they all pass. You know, those that pass are good to go. The test is really stringent, and if you want to do some research and find, people making that test on rooftops, it is a fascinating thing, and it's hard to believe they actually survive, but if it's built this way, they'll actually survive. So that was the first thing we did. Then over the years, we've been limbing up trees and getting out the low-lying vegetation, and we trim uh, the weeds and stuff every year to try to avoid a surface fire. And then in the front of the house, you'll notice there's some birch trees in the front of the house. In the back of the trees facing the house, those limbs have all been taken off so that the limbs can't fall down on the rooftop, theoretically. Um, at some point, I'll be taking these birch trees out. They don't live forever, and they're not, the one in the center there is not doing well. So these will probably all come out. Um, we had wooden fences around this house when we moved in here, and I've taken all the wooden fences out and replaced them with steel. Windows in here were originally single pane windows in the house. We replaced those with large commercial double pane windows with aluminum frames. These windows are not they're not tempered glass. The tempered glass is in the patio doors, but not in these big windows. Although these because the windows are large size, that the panes tend to be very, very thick. We had a lot of vegetation close to the house. In this case, you can see these large shrubs right under the eaves. And you'll notice on this house we have unusually wide, unusually broad eaves. Um, the designer who did this house did a lot of stuff in Silicon Valley and designed these uh, sort of Silicon Valley style buildings that have tilt ups but have large roofs with broad eaves. And he's the one who did this house. And he loved the eaves that big, and without realizing that it poses some fire danger when you have those large eaves out there because you've got so much vegetation underneath them. Here's another case where we've got some shrubbery here. This has all been cut back. And you can see how close that shrubbery is to the eaves. And this brings up another point. The sloping lot, because of you can see how this is sloping from here. A lot of this vegetation is closer to the roof and closer to the eaves than it would have been if this was a flat lot. I started looking into wildfire hardening and how fire moves, and there's literally hundreds of videos on YouTube you can look at, and this in particular points out a couple things that struck me as important. First of all, this area right here, you can see how this mulch, which looks like a redwood bark mulch or something like that, has has pushed those flames right up to the side of the house, and you can see how right at this low portion of the siding, these cedar shingles are igniting right at the tip of the cedar shingle as it sticks out there. So the fire tends to move across there and get to those low-lying areas and light them up. These are some shrubs that started fire, and you can see on this side over here, those shrubs are right up against the house and lit the house on fire, and this on the siding. What was surprising to me is that there was enough in the burning embers and enough heat to start the fire up under the eaves. And you'll notice you can hardly see it here, but these eaves are not covered. There's just the underlayment and the rafters showing there. On the other side of this test house, this is they didn't say what kind or brands or anything, but this is a non-combustible siding on this house. So I looked up non-combustible siding of various kinds, and one of the things I saw was this Hardie board. Um, in this test case, they used like propane blow torches, four of them against these things to light them up, but the Hardie board just didn't ignite. So sounds like a good candidate. I looked at other houses that had Hardie board and had been through a wildfire, as in this case. Um, in this case, this siding, all the siding on here is cement board siding, but they didn't they didn't use cement board for the corner boards. The corner boards are cedar in this case, and the wildfire came from the ground and just ran right up these corner boards and would have gotten into the eaves and could have uh, destroyed the house. But the fire department arrived in time and this house was saved. But the point of this discussion is that the details really count here. It's kind of an all or nothing thing. Your house is either going to be ember proof, non-combustible, or it's not. And the devil is in the details and getting these little things right. The corner boards were a problem. So about a year and a half ago, of course, we had the wildfires in Los Angeles, and that really made me get serious. So I started studying the homes around this area in Pacific Palisades to see, what could be learned by looking at these houses that survived. In the case you see here, the house on the right survived and looks virtually untouched, but everything else around it burned to the ground. And it turns out that this home was designed by an um, architect owner. He designed it with 1 hour fire rated external walls facing the neighbors' walls, and then used all kinds of other things that we know would work well in this case. The metal roof, windows are all metal frame windows with double pane and tempered glass in the windows. You'll notice the zone zero vegetation is, complies basically with the, what we want to do and keep that 5 foot area free of a lot of debris and stuff. So this house survived. Um, it turns out that other houses survived. In this case, I just happened to decide just about a week after the fires, I just decided to take a look at the destruction in the Pacific Palisades area. And so I went to Google Maps and looked from the satellite view of Google Maps, and you can see in this case, there's a house here. Um, excuse me. There's a house here that one house that survived on this block of houses here. Um, and I thought, well, clearly some houses are surviving this thing. There are others around this area too that has survived, but I picked this one in particular. And I thought, well, God, I'll just take a look at the street view and see what this house looks like from the street view. When I looked from street view, the street view has not been updated. The street view still showed the area before the wildfire, but the satellite view showed the area after the wildfire. So this provided a unique opportunity to look in here and see things that survived. You could pick out the houses that survived and then take a look at seeing, well, what is it about that house that caused it to survive this devastating fire? Well, here's a more close-up view. This is again street view just before the wildfires. There's vegetation everywhere, all close to the exterior walls, hedges between the properties, no defensible space. And yet this house survived. 1 year after the fire, even in the worst conditions, a house can survive a wildfire. That's what the message here to me was that if I do this right, even in the worst conditions, the house will make it. Uh, there was some press and some articles written about this house in particular, and this one was ventless. It didn't have rafter vents or crawl space vents. It was an airtight enclosure. They talked about some exterior insulation being thick, but they didn't describe much about it. What they did say, though, is it used industrial grade fire resistant materials. I checked and they used Hardie board in this case, the cement board siding in this case. Clearly, that picket fence around the front was made with something that was non-combustible. Uh, but the point is that if we do this right, we can survive. So I come back to my house and I look at the condition, and there have been a number of cases where I had people from Woodside Fire come out, and we walk around the property, and they point out things that are risky that I've got on the property, and this was one of the risky spots. Here I've got kindling right under my deck. Um, these redwood lattice pieces, or it's something. A lot of us use this redwood lattice on things like in here. And these uprights, these 4x4 uprights were redwood in this case. So I've got redwood lattice and redwood support structures in here and it's right next to a lot of vegetation. So I decided to take out the redwood lattice, remove that, and I was going to put up some metal panels, some metal decorative panels. But I looked at the redwood posts that were holding this up, and I thought, well, that maybe they won't burn, but what if I'm wrong? And so I had neighbors who were using some Hardie board on a couple of things, on a couple of projects over here. So I went down to the store and found uh, some Hardie board panel material, and I uh, cut it into strips, and I surrounded those redwood uprights with Hardie board, so that now those redwood uprights are basically non-combustible. And so the amount of vegetation in front of them it won't be enough to cause those redwood posts to ignite. So then what I added in here are these are if you look on Amazon, for example, and you look up privacy panels, these would be about 6 feet tall, 4 feet wide, and they consist of three metal sections stacked. And so what I did is I bought several of those privacy panels and just mounted the privacy panel steel pieces right up against those uprights that I'd covered with Hardie board. So now there is nothing to burn here. There's a little bit of vegetation there, some azaleas and some ferns, which we keep watered, of course. They may catch fire, but they can't cause anything around them to catch fire because that's all at this point non-combustible. So then when I finished this project, I started thinking about, well, what about the rest of the property? Uh, nice job, Terry. You got those four uprights uh, uh, non-combustible, but what about the rest of the house? Well, I started doing a little more research, and um, one of the things that was mentioned was uh, if you have about 8 inches between the grade level, that is the soil level on the ground, and your exterior siding, Burning embers that pile up and get, windswept against the house may not be able to ignite the exterior siding. So there's an area there. If you had 8 inches, um, you might be okay. Well, I looked around my property. I don't have 8 inches anywhere. My siding comes right down to grade level. It comes down to these patios, this concrete patio area, and so that's a problem. And I thought, well, I could just cover these, uh, put new siding on, for example, cover the redwood siding with Hardie board. And um, I heard people have done that. It's common practice. And so I uh, I looked it up and looked at the construction techniques used to put Hardie board over redwood siding. The redwood siding on our house is put up against the stud wall, and the redwood siding is providing the shear wall, so providing the torsional support on the exterior wall. So the redwood siding can't be taken off. Um, So the trick then is to put Hardie board over the top of the redwood siding, and what's required is when you put that new layer of Hardie board or cement board siding on, it requires uh, a a vapor barrier inside there underneath it. So then you end up with this stack up of the original vapor barrier, the redwood siding, a new vapor barrier, and the Hardie board siding. But what if burning embers get underneath here and stack up and get under here and ignite the redwood under the Hardie board? That's possible. And I'd seen some fire professionals recommend doing something about that. And James Hardie Company, in fact, said the way to fix that problem is to take an aluminum bracket and put that aluminum bracket in here and then put your Hardie board over that aluminum bracket so that there's no exposed wood under here so that burning embers can't get to the redwood and ignite it. Then there's a similar area around the decks. Now in this case, this wood on the deck is Ipe, which is a Brazilian very hardwood that is has a Class A fire rating. Um, so in this case, that ember bracket is put in here over those deck boards so that there's no place in there where the embers can get into the redwood siding or get between these deck boards and the redwood siding against the house. So in order to do that, we've got we've got uh, we've got an ember stop guy here. Uh, he's got an 8 foot bending brake, and he made these brackets custom made the brackets on site here to install on the property. And you can see here, you can see those brackets installed um, uh, over the redwood siding here, and you can see them on the bottom here, just above the cinder block wall around the perimeter of the house. So all of the redwood was covered with these ember stop brackets around the entire property. Then then the guys came in and put the vapor barrier, the weather barrier over the top of the existing redwood siding and over those ember brackets. And then these guys installed these 4x8 panels of Hardie board cement board siding over the weather barrier. And then this is the caulker guy. Caulker guy goes over the entire house, every joint, every 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 butt joint here, and every joining panels and everywhere in the entire house and caulked every single thing so that there is no crack anywhere for any embers to penetrate the property. And you can see over his head here how um, we put soffits under the eaves, so we don't have exposed rafters under the eaves. There's no exposed wood under the eaves. Originally, I thought maybe I don't need to do that, but after I saw that, the slide we saw earlier with the house that was burning under test, where even with the seemingly invisible embers being driven against the house, it lit the eaves up and the house was burning. So that's why we decided to do soffits. And what you'll see here, this is a soffit vent. This is made by Vulcan and recommended by Hardie board to do these softening in the vents. Uh, then we installed Vulcan vents in the crawl space area there. We have ember-proof ridge vents installed by the roofing company in the on the top of the roof. And then again, you can kind of see um, this rafter cavity vent that extends the entire length of the eaves here. And then I thought, well, what about the door jambs? Wind created by the wildfire will cause swirling currents that's going to deposit embers inside corners around the structure, and burning embers may collect in the lower corners outside the doors. So in this case, the this guy who was running the bending brake made some aluminum covers to cover over the uh, door jambs here to protect the door jambs in case embers build in the doorway. Then in some other places, like in this case, for example, the door jamb was just covered with Hardie board materials. This piece is a Hardie board trim on the outside against the outside wall, and then there's a Hardie board trim piece here, and then the trim that goes actually against the door is here. Um, and then you can see how all this stuff is carefully caulked so that there won't be any cracks or anything in there. In this case, we just covered the entire door with a Hardie board panel, and then of course all of this trim work around here, all of this is cement board trim work that was put on all around the door. And in one case, we really couldn't cover this whole door, so in this case, we elected to put a skirt on the very bottom of the door. This is again cement board material, and so now all this trim and the siding is all cement board. This is cement board up about here about 12 inches. So if embers collect in these corners, there's nothing for them to ignite. The threshold in this case is aluminum, so it won't ignite. The challenge here was the front door. This front door has these redwood panels that have been milled to get this raised effect. Um, I really like that effect, and we have everything else here. This is all Hardie board trim, Hardie board panels on the side of the house, Hardie board trim in here. We covered these door jambs with aluminum. It's aluminum threshold, but what do we do about this? So took a 1 inch thick piece of Hardie plank material, um, I believe 7.5 by 1. Took it over to a machine shop and had them mill out this panel of Hardie board, painted it and replaced these lower 7.5 inches here with panels that are actually cement board now instead of redwood. So if embers collect in the corners here and bang up against that door, there's really nothing that it can ignite. Uh, Next, we wanted to take particular care with the the ends of the eaves, these corners of the eaves. Again, the eaves are so broad that they could easily catch embers and get hot enough under there to ignite. So in this case, this gable rafter out here has this is a cement board cover over the gable rafter, and then in the rake fascia in front of the right under the gutter there, that's a thinner piece of Hardie board. And then, as we talked about before, these eaves have been completely soffitted and enclosed. So years ago, we put on these metal gutters with metal gutter guards. So now, in this case, there is no exposed wood on any part of the corners of the roofs here. Uh, we talked a little before about the design of the house with these unusually broad eaves, and because of the sloping lot, um, I wasn't sure if I could get away with leaving the exposed eaves, and so uh, I decided to soffit the entire property, all the eaves everywhere. But what about the ridge beam? Ridge beams are 4 by 12 Doug fir likely. Uh, they used to extend beyond the eaves, but we cut them back, and you can see how we put this Hardie board over the edges here. This is um, the ridge beam. Uh, the soffit material in here now comes right up to the ridge beam, so there's no way that embers can get up and rest on top of the ridge beam any longer. And the ridge beam is so thick and it's so high off the ground that we, in my judgment, there was not enough mass, or the mass is so large that there's not enough flame that could get up there, or enough heat that could get up there and ignite the ridge beam. So we left that uncovered. But the ridge beams are the only exposed wood on the property or on the house. The original garage door was made of the same redwood panels that the house was made of. So it was certainly vulnerable. We replaced that with a double-sided steel door with insulation, and then around the edges of the garage door, uh, these guys recommended using these seals so that when the door closes, it presses right up against that seal, so there's no space in there where embers can be driven into the garage. Um, I'm hoping that if embers collect on the bottom, that the um, that seal doesn't catch fire, but a risk I'm willing to take. These these railings used to be wood. We replaced them with steel. This is this doormat. Um, Doormats were a concern. Most of the doormats we see are made from cocoa fiber or some natural fiber and are combustible. So I did a little research and found a company that makes a commercial non-combustible material doormat. And this specification is CPSCFF 170 describes the test method for surface flammability of carpets. And so in this case, these mats, if embers get on those mats, the fibers may melt, but they won't support an open flame. And that's the main thrust of that specification, is to have something that doesn't support an open flame. Then originally we had wooden retaining walls everywhere and wooden steps in these things, and we replaced all that with steel reinforced concrete walls and put in decorative stone there. And so now this is, remember earlier in the presentation, that slide with all the vegetation growing up into the eaves. Well, this is where it was. This was just thick with there was a 50-year-old Japanese maple in there and a bunch of other shrubs that were just totally overgrown. And so all that stuff's been removed. We planted just a few azaleas and ferns in here, which are, some distance from the side of the house. And and keep in mind that siding, everything in here is non-combustible. And so in this zone zero space in here, we put in these large river rocks so that when my gardening staff comes here, they can blow that out, really with a heavy leaf blower, blow that stuff out of there, and those rocks won't move. I looked at putting in some kind of gravel there, but the problem is with small gravel, with pea gravel or something like that, if they come in here with a big leaf blower and really want to get that stuff out of here, it starts blowing those little rocks all over the place. So so we put in big ones. And um, does it look good? Yeah, I think it looks good. I'm happy with it. I'm happy. It looked worse when it was overgrown, frankly. Um, And this is a photo of the original railings and decks and all the stuff that surrounded the house here. These railings were redwood, the decks were redwood, and uh, and these railings go right up to the redwood on the edge of the house. Um, so we replaced those with that is, we replaced the railings with steel. And this deck material again is Ipe. The Ipe wood routinely gets a Class A rating uh, when tested against ASTM E84. So then all this furniture here, the lawn furniture is all aluminum. And I just have to remember to throw those cushions in the house before we evacuate. And the propane tank. Well, we had a wooden shroud around the propane tank, a wooden decorative fence around the propane tank. And to make matters worse, I used to store firewood around there. And bad idea, Terry. So we took that out and built a steel reinforced concrete wall and put decorative stone around it. So no, I'm not storing firewood around the propane tank any longer. And originally, there were light fixtures around the perimeter of the house that were site built, and they were made of redwood. Birds would nest in them and bring more kindling under the eaves. So we replaced those with aluminum commercial fixtures. And then the dryer vent. Um, you know, I okay. I used to be an engineer. I'm a retired engineer now, so I'm into details. So there's an aluminum dryer vent here now that has a little aluminum spring-loaded door in there so that embers can't get pushed back into the dryer vent. And embers get in the dryer vent, melt the hose, and burn your house down. So the dryer vent's okay now. Um, no holes. So in any places where things had to enter the property, where they had to go through a wall, those things have been uh, carefully managed and caulked so that there's no cracks or anything there where something can penetrate the into the house. Cable service here is buried, comes into a box. The cable company put a plastic box out here on the wall, which plastic flammable box against my house. And so we replaced that with a steel box, and So embers might lay on top of that box, but the box can't ignite, and all that trim and the Hardie board on the side of the house is non-combustible. Then under the lower deck, under the ground level deck, there's a decorative skirt here, and behind that skirt is a metal screen to keep leaves from collecting under the deck. And then in this planter box, in the planter boxes, for example, this what you see here, this gray material here, that's cement board lining that we put inside of all of the planter boxes so that embers can't get in under the deck or into places where they could light something. The fireplaces have all been replaced with gas inserts. So there are no more embers going up the flue, but additionally, that means we don't have to store any firewood on the property any longer. And then the doggy door. Uh, you know, I know I'm getting really picky here, but the doggy door is flexible plastic material, and if you've had these doggy doors, they have a locking panel that's inserted inside the door when to lock it out. But the insert here was plastic, and so what's the probability that embers are going to burn their way through the plastic flapper door and light the plastic on the inside here? I don't know. I don't think it would burn. I don't think embers would get in the house, but what if I'm wrong? So I made an aluminum doggy door panel there. This this doggy door panel to lock it, and a little locking knob on there to secure it. And then the umbrellas and furniture and all are steel or aluminum, but the umbrellas will have to be taken down, and the cushions will have to be thrown in the house, as I mentioned before we evacuate. Then there's the trash can storage area. This had wooden doors in the trash can storage area, and they, of course, were liable to burn, and they were right under the eaves, adding fuel to the fire, if you will. And so we mounted those same decorative privacy panels on the outside of the trash can doors, so that there's nothing flammable there. The problem, however, is the cans themselves. These trash cans are not fire resistant. Um, Now we have a metal screen that's mounted over the top here. I don't think you can see it in any of these photos. Well, maybe you can see it in this photo. Um, there's a metal screen that's on the top. It won't necessarily keep all the embers out. This was designed to keep critters out of that area, particularly raccoons. And so we'll just have to take these cans and move them farther out from the house just before we evacuate. So we got all the stuff done here. The building inspector has a smile on his face. If the building inspector is happy, I'm happy. Uh, and uh, so will the wildfire come through our area? I don't know. The probability is very low. Is my preparation overkill? I don't know. Will it pay off? I suspect, but I certainly sleep better at night. So thank you.
That was great. That's so much work. Again, the first time I watched this, I was like, wow. And again, I'm astonished. Um, for anybody who has questions, you can go ahead and raise your hand. We do have a little bit of time for questions. And we do have one in the chat that says, I'm interested in a rough estimate of the cost for covering his existing siding with Hardie board.
That's a terrific question, and I should have addressed that. I'm really glad you asked that. The way I looked at this, I priced it, I got quotes from a couple places, and it's not cheap. But the price to do this whole house like that was about 3.5% of the value of the home. So is that good? Is it bad? I don't know. It depends on how you think of it. And for my wife and myself, we we really want to save our house. It's unique that we've collected things all of our lives that are unique, and you know I'm an old guy. I don't want to start over again. So it was worth it to us to spend that kind of money to get the house basically uh, non-combustible. A lot of the things you could do for far less money, but putting the hardy board over the whole exterior of the house and under the eaves is that's where the money is. Now I have a neighbor who put a skirt around the bottom of his house that's about 18 inches high to protect that most vulnerable area against embers coming up against it. But that's another way to approach the problem. But the cost is, it's not cheap. But when I looked at it as insurance, it's certainly less than the deductible for the fire damage. So.
Thanks, Terry. Does anybody have any questions for Terry? Now's your time. Now's your opportunity.
So did I do enough detail work here, do you think? Did I cover everything?
I feel like you covered everything to the point where people didn't have questions about it. Oh, there's one that just popped in. First of all, yes, the presentation will be available. Once I post it on YouTube, I'll share it again on the groups.io. There's another question that says, how has this affected your insurance coverage?
Um, that's a terrific question as well. And there have been some discounts for doing this kind of stuff. And in fact, State Farm has a menu of discounts for various different things. I don't recall all of it off the top of my head right now, but there are a number of discounts. It's not a whole lot, but certainly every bit helps.
Okay, we have another question. It says, will Terry share the names and contact info of the crews he used, please? How recent was this work done?
This work was done 1 year ago. It was last summer that we had the work done. And the first thing I did was contact the James Hardie company. They provide the names of Hardie board certified contractors. And the problem with this material is, and getting contractors to do this is, the material is extremely heavy. The boards and the panels that, a 4x8 panel of this stuff weighs 78 pounds. And so it's difficult to work with. And you can't pound a nail through it. They use special nailers with hardened stainless steel, basically big brads that they punch through this stuff. So I got some names, and I can't recall a company in Oakland gave us a quote. Then I got a quote from a company in Sacramento that I chose that actually did the work. Uh, their guys uh, came down on Monday morning and stayed at a hotel here and worked, long hours. This was the company is Pro Superior Construction from Sacramento, and uh, guys were just terrific.
That's awesome. All right.
All right.
I, I'm Lori here. I have one more question.
Yes.
Thank you. Terry, since the hardy board is so heavy, did you have to put more supports in anywhere?
No, we didn't. And that's a good question, but it's right up against the edges of the house and everything. There didn't seem to be any structural questions.
Thank you.
Although an interesting comment. Um, we had an original garage door, as I said earlier, was made with the panels that um, were used on the outside of the house, redwood siding.
Hmm.
And so I thought, well, why don't I just take about an 18-inch section of Hardie board and put it on the bottom of the garage door so that embers coming against the bottom of the garage door can't light that redwood. So I put that stuff on. We had the panel put on the bottom there. But the old garage door motor and old garage door, we'd hit the button, it wouldn't raise the garage door, right?
Yeah. All
So
right. Thanks.
and we the garage door was basically shot anyway, so we just took the whole thing out and replaced it with a new garage door. That was the only place that we had a problem with the weight.
That makes sense.
Yeah.
There is a question I don't have an answer to. I don't know if you've heard anything about this, but it says I'm curious about mesh that allows airflow, blocks bugs, and prevents fire intrusion. Any experience with this, and what did you find work? What did you find works? It says for covering windows.
Okay. We didn't do anything specific for windows. We have metal frames. That's important. Double panes. Um, the windows that survived in Pacific Palisades tended to be metal frames, uh, double pane windows, and in at least one case they were double pane and they were tempered glass. And if you were to buy new windows to get windows specifically designed to withstand a wildfire, it would be um, metal frames, double pane, and tempered glass.
And I think in the idea of when a fire's coming is obviously you're closing the window. So
Yeah,
the screen wouldn't even matter anyway,
yeah.
depending on your window.
We do have some screens in some places in the patio doors where they have screens, and in those cases, that screen's gonna melt.
Yeah. Yeah. Well, I really appreciate everybody hopping on here and Terry especially for the amount of work that you've done to your home and as well sharing your experience with the community. We really appreciate it.